Good morning, fourth graders. It's Mrs. Mauer coming to you from my dining room for Friday fun with Mrs. Mauer. Woo! All right, so we have a video lesson today, and then I will give you some time to work on it. So if you could have your workbook out with a pencil and get ready to follow along. You can pause this video at any time. So have your workbook, be ready to write, and again, you can pause it at any time. So I'm going to share my screen with you and get the presentation going. Here we go. All right. It looks like we have our problem of the day, and we'll do the concept of the day next week when we were talking about our geometry and our quadrilaterals. We'll continue that Monday through Thursday, okay? So, problem of the day. Bruce cycled 6 miles last week. Patrice cycled 5 times as far. Draw a diagram to represent how far Bruce cycled and how far Patrice cycled. How far did Patrice cycle? So, you may be thinking in your head, 5 times as many. It tells you right there what to do. But they want us to draw a diagram. So, in addition to what you're already thinking of what operation you're going to use, draw a diagram. So if it was 6 miles last week and 5 times as many, I will need the number 6. And I will need it 5 times. So my diagram, I'm using counters. I have 6 once, 6 twice, 6 3 times, 6 4 times, and 6 5 times. And you're probably also thinking in your head, what is 6 times 5? Well, 6 times 5 is, that's right, 30. Woo! So Patrice cycled 30 miles last week. Now again, when they ask you to draw a diagram, counters is a fast way to do that. Or a counter like that is fine too. Okay. Great job. And look at that. They did it a different way. They have 6 5 times, which is probably a faster way, but I did want you to see the visual. 6 5 times. 6 6 6 6 6. Repeated addition there. 6 5 times is 30. Awesome. Mary attended camp for 7 days this summer. Tyler attended 3 times as many days as Mary. Find the number of days Tyler attended camp. So again, you're thinking you have the number 7, and your next number will be 3 times as many. And you hear it right there what to do. But of course, they want you to use counters. Okay? So you're going to use counters 7. Oops, sorry guys, my hand is dragging. 1 2 3 4 5 6 and 7. 7 days. Okay, that was Mary. Tyler went 3 times as much as Mary. So if Mary has 7 and Tyler went 3 times as that, I'm thinking I need 3 of those. So go ahead and visualize the counters 3 times. And what would 7 times 3 be? 7, 14, and you guessed it, the fabulous number 21. So 7 3 times with counters is 21. So Tyler must have gone 3 groups of 7 to be 21. Da 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 da, Mary had 1, Tyler had 3. So if we're taking that same example, find the total of the 3 groups. So we have 7. We're writing it as a repeated addition now. 7 plus 7 plus 7 equals 21. Or 7 times 3, which is, you guessed it, 21. So Tyler attended camp for 21 days. Now, this seems repetitive. However, you should know that repeated addition is a great way to solve a problem. If you don't know the fact, it's a great strategy. You used it when you were first learning multiplication, and now you're using it for seeing groups. Look at that. Ta-da, da-da-da-da-da-da. All right, example 2 is using a bar diagram. They're kind of showing you the groups that way. Suki used 15 beads to make a bracelet. So you can see 15 is my total up top. This is 3 times as much as Cassidy, okay? So 15 is 3 times as much as what Cassidy used. So you have to think, if my whole is 15, that's 3 times as much as the part. Oops, sorry. Go back. And we're thinking 15. This is 3 times as much, so you can think division here because you're going backwards. And what would that be? Or you can think of, it is 15. She did use 15. We know the total. And this is 3 times as much as Cassidy. But since we don't know what Cassidy is, you can use mystery box. Or you could have written 3 times C, because it's our unknown, which is 15. Ta-da! All right, now 3. Cassidy had 3 and Suki had 15. 15 is 3 times as much as Cassidy. Okay, so 3 times what? Ooh, did I put 3 there? Sorry, let me go back. 3 times as much. So what is the unknown? Our unknown is, dun, da, da, da. You guessed it, 5. 3 times as much. So she had 5, that's 3 times as much. So you can also think 3 times as much. This is what I just wrote. Right here. So Cassidy used 5 beans because it told us that Suki used 3 times as much. And 3 times as much, 15 is 3 times 5. It's kind of hard to think through, but it makes sense when you break it down. All right, we're going to take a break for 1 second, so stay tuned. Da, 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 da. Stop share. All right, coming back, coming upstairs. Okay, now I'm going to share my screen again. Now let's try together, okay? So we're going to use the multiplication or division to complete the equation. Now this one's kind of obvious. It's so obvious that you're like, am I doing this right? 3 times as much. So I have 3. They want to know what 3 times as much is. So I'm thinking, well, 3 times as much as 3 is right here. So what is that fact? 3 times is da, 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 the number 9. Awesome. We did it. Hooray. Talk math. One way to interpret 24 equals 8 times 3 is to say that 24 is 8 times as many as 3, which is true. you could also say 8 times 3 is 24. Oftentimes it's written like that. This is still true even though the 24 is on the left. Now you try. We just did one together. 3 times as many. Okay, so I'll do the first one and then I want you to pause and do 3 and 4. 3 times as many as 1. I'm thinking 3 times 1. So go ahead and put that in. 3 times 1. Oh, look at that. They have the answer for me. It is 3. Now you try 5 times more. They need this number 5 times more. And then 4 times as much. I have this number, but I need 4 times that number. What would it look like? And drum roll, please. Ooh, that was not what was supposed to happen. Oh dear. Okay, stop that. Oh dear, oh dear. Wrong drum roll. Should have put. All right, let me stop again and then I will pull it back up. I'm not sure if it stopped or not, but either way, here we are. So, dun, da, 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 there it is. Now, we're going to have some more independent practice. 10 times as much. 10 times as much is something, and I have to get to 40. What number would fit in the box? That's right, the number 4. So, if 4 goes in the box, guess how many counters you're going to draw? 4. 1, 2, 3, 4. So again, you're just visualizing these things right here. You should be able to do those with numbers. 2 times more, 10 times as much, twice. The number twice means 2, okay? So when you hear those and you're given an unknown number, you should be able to multiply and do that. Today is simpler with counters. So go ahead and finish those. Pause me and finish those. And dun da da da. Again? Oh geez. Okay. We got to stop doing that. Let's try that again. There it is. Perfect. Great job, 4th graders. Now, let me just double check that Zoom is still on. It is. Okay. And here we are. Again, we have it now with the bar diagrams. Twice as many as 4 boys. So you're thinking 4 boys twice as many. So these are great visuals. Okay, 4 once, 4 twice. Twice as many as 4 boys. Now you try 2 times as many as 3 bows, and then fill it in. And 4 times as many as 6 fish. Pause me now. Give it a go. Dun, da, da, da. Now this one was 4 times as many as 6 fish, okay? So if you need 4 times as many, you would need the 6 4 times. And you saw that they had 4 boxes. All right, your turn. You can draw bar diagrams 3 times as much as 6. So you would take 6. We don't know the unknown, we don't know the total, but we know that we need 3 times as much as 6. So 3 times, I need 6 once, 6 twice, 6 3 times. 5 times as many as 1 star. So I need 5 times as many, 5 times. Dun, da, da, da. All right, our problem solving question today. Draw a bar diagram and write an equation to solve. There are 3 times as many balloons as, there are 3 times as many blue balloons as green balloons. There are 4 green balloons. How many blue balloons are there? Okay, so you're thinking in your head 3 times as many, and there's 4 green. So how many blue? So you're probably already thinking 3 times 4. So that can be our equation. And that was right here. There we go. Okay, so we can draw. We can model using a bar diagram and write an equation. 3 times as many. 3 times as many as 4. Find the unknown. Blank is 3 times as many as 4. The unknown is 12. What does this look like for our bar diagram? There are 4 green balloons, okay? So 4 green. And blue is going to be 3 times as many. So we don't know we have our unknown, but we know that there are 3 times as many. So we have 4 once, 4 twice, 4 3 times, because 4 is what we do know, and we know it's 3 times. So what is our unknown? 4, 4, and 4. Dun, da, da, da. Yay! Now, I have to be careful when I do drum rolls and dun, 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 because every time I do it, my screen goes crazy. All right, same thing. Draw a bar diagram and write an equation. Nan needs 4 times as much flour as sugar. She needs 4 cups of sugar. How much flour does she need? So we need 4 cups of sugar. We need 4 times that for flour, which sounds a little healthier than 4 times as much sugar. So we have 4 times 4 this time, which is, in your head, you're thinking, I know that fact, 16. Dun, da, da, da. And then I have 4 times as many. I don't know this. I have my unknown. And then I have 4 times as many. It's a question mark. Now my bar diagrams are not as fancy as the books, but I still like to use them as a visual. This might not be your favorite thing, but you can always at least draw 4 once, 4 twice, 4 3 times, 4 4 times. Or if you're really stuck, you could use counters. Da, na, 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 na. Woohoo! All right, kiddos. Well, if you'd like to follow along and do the brain builder, you can. They want us to circle the example does not belong. Explain your reasoning. So I have 4 3 times. Looks like I have 4 3 times. And it looks like I have 4 3 times. And 12 minus 4 equals 8. I wonder which one doesn't belong. You guessed it. This one. Now this one would belong if it was repeated subtraction the right way. It does not fit because it does not show the relationship like these 3 do. Da-da-da! Multiplication fact families. This could have been a part of the division, but it was not continued. The other examples represent a multiplication fact family or repeated addition. Now, we're going to talk about that brain builder back in class. You can start on your homework. 4 times as many, they want you to write the equation or the number sentence. So basically, 4 times more. So I have 1, 2, 3, 4, 5. I would write 4 times 5 because it's 4 times as many as I already have. And what is 4 times 5? Bum, ba-da-da, 20. So you'll finish those. Oops. And then you'll finish the back side. I can't go on anymore because I'm sneaking you answers. And we can check those, okay? Actually, you know what? I will show you those because then you can maybe work backwards if you need to, okay? And feel free to pause at any time. Brain builder. All right, now again, before you check your answers on those, please work through them on your own and see how you do, okay? And go back and see how you did. I also would like you to continue at some point, at least one time tonight or this weekend. Again, continue your facts, multiplication facts. I'd like you to go through 12, okay? You should know them in a few seconds. If you struggle with 8s, you should work on 8s. If 11s and 12s are the hard ones, work on those. Again, I'd like you to know them within a few seconds. Maybe we'll do a fluency check and just see how it's going. I'm fine if you use your songs and fingers. The more you use them, the less you'll need them. So go ahead and use them for now. And then we will try to not depend on them as much as we keep going, okay? All right, 4th graders, we'll have an awesome weekend. And we'll go through this on Monday. And if you need anything, email me. Otherwise, good luck on this lesson and on your multiplication review. And I can't wait to see how you did. All right, take care, stay warm, and get out in that snow. Peace, mathematicians. Bye.